Chapter 3, 3.2, The Gas Laws. Pressure is the result of force distributed over an area. Your text discusses a hockey arena and shatterproof glass around the rink getting hit by a puck. If you're unfamiliar with hockey, don't worry about it. Think about an indoor soccer arena. And sometimes near the goals or above the baseboards, they have some shatterproof glass. If you hit it hard enough, or if a player hits it, it's possible not necessarily to shatter it, but it could crack. If you prefer a totally different example, let's think about a rock hitting a car windshield for a moment. When a rock hits a windshield, the cracks that appear can be delayed, or they might look like a tiny chip in the glass. But the star-shaped pattern that eventually appears shows that the damage must be fixed. Without fixing it, the windshield will continue to crack under stress, and that stress can come from severe weather or more pressure of some sort. There are short demonstrations on a link provided in today's lesson on Schoology. Please do take a moment to check those out. You are not responsible for reading the materials associated with it, but there are two short videos that show what that looks like when the damage is being done. Collisions between particles of a gas and the walls of a container cause the pressure to increase in a closed container of gas. The more frequent the collisions, the greater the pressure of gas is. Speed of particles and their mass also affect pressure. In the image, the red and blue circles collide, causing additional pressure as noted by the little extra lines around the shapes. Factors affecting gas pressure. Temperature. Raising the temperature of gas will increase its pressure if the volume and number of particles are constant. In Chicagoland winters, many of us have to add air to our tires frequently, and this is because the pressure decreases in our ridiculously frigid Arctic weather. If the air is not replaced, the tire reads low to our computerized car systems, and it decreases our gasoline mileage and the vehicle response times, which can lead to accidents. If, however, you are driving down south in the very same vehicle, the warmer climate and heat reflected from the pavement increases the tire pressure. We need to keep an eye on that pressure as well to prevent the tires from overfilling the air that causes slower braking, increased wear and tear, and sometimes even tire blowouts. Volume. Lowering the volume of gas increases its pressure if the temperature and number of particles are constant. Number of particles. Increasing the number of particles will increase the pressure if temperature and volume are constant. And this example goes to both volume and number of particles. Put your hands on your ribs and take a deep breath in. This is known as inhalation. You should feel your rib cage lift up and out as the air moved into your expanding lungs. This is an increase in volume, but the pressure is decreased because there's more space for the movement of particles. If you blow the air out of your lungs slowly, keeping your hands in place, this is known as exhalation, you should feel your rib cage move down and in as the volume of air inside the lung decreases. Since the volume of air is less than it is at inhalation, the movement of the particles lessens because there's less room to move around. This increases the pressure inside your lungs. All right, for Charles's law, and sometimes you'll see that as CHARLES', and sometimes it's without the second S. The volume of a gas increases at the same rate as the temperature of the gas. V1 over T1 equals V2 over T2. Boyle's law. The volume of a gas is inversely proportional to its pressure if the temperature and number of particles are constant. P1 V1 equals P2 V2. The combined gas law. Boyle's and Charles' laws can be combined into one law when particles are constant. It describes the relationship between temperature, volume, and pressure. P1V1 over T1 equals P2V2 over T2. For your assessment 3.2, please handwrite your work, and that will be due Monday at the end of class. The first one, how is the gas pressure produced in a closed container of gas? 2, what 3 factors affect gas pressure? 3, how does increasing the temperature affect the pressure of a contained gas? 4, what happens to the pressure of a gas if its volume is reduced? 5, how does increasing the number of particles of a contained gas affect its pressure? 6, what happens to the pressure in a tire if air is slowly leaking out of the tire? Explain your answer. Number 7, what do Boyle's law and Charles' law have in common and how are they different? Number 8, some liquid products are sold in aerosol cans. Gas is stored in a can under pressure and is used to propel the liquid out of the can. Explain why aerosol should never be thrown into a fireplace or an incinerator.